everyone. So in this presentation, I would like to talk about the RVLM neurons and cardiac regulation. Beforehand, what is the RVLM neurons? Previous research has shown the importance of RVLM neurons in regulating the sympathetic activity through stimulations of the splenic nerve. And RVLM neurons itself is a sympathetic preganglionic neurons that participates in regulating the cardiovascular system. In terms of the input, as a preganglionic neuron, RVLM neurons receive inputs from the baroreceptor, and it also receives input from other peripheral and central sources, which in results will control the vasoconstrictor and arterial pressure of the cardiovascular system. RVLM neuron is also suspected to be involved in the visceral sympathetic reflex, since the activations of visceral afferents will affect change in cardiovascular sympathetic nerve, blood pressure, and heart rate. RVLM neuron is also found to have an excitatory and inhibitory responses, which mediated by the GABAergic and glutamate input into the system. GABAergic input will induce the inhibitory response, which will lead to the reduced sympathetic activity, while, on the other hand, glutamate input has an excitatory response that will lead to the increase of the sympathetic nerve activity. Therefore, we can conclude how these inputs may contribute in maintaining the homeostasis of the cardiovascular system. This is where the importance of homeostasis of this regulation comes into the center of attention. In previous research, it has been found that the hypertension rats have an elevated sympathetic activity. Most interestingly, the GABAergic input is also found to be reduced as well. As what we have mentioned before, GABAergic input is important in maintaining the inhibitory response. So reduced GABAergic input will lead to uncontrolled and higher sympathetic activity. So the question arises whether there is an altered or impaired cardiac regulation through RVLM neuron in the hypertension. This question becomes a focal interest in my current research. Thank you for your attention.